This video is about three forms of complex numbers. Z equals A plus BI is also called Cartesian form. You can plot this complex number in this Argand plane. Real part of complex number, imaginary part of complex number. Think about this is A plus BI. Then this is A, this is B. We also have a modulus argument form of complex numbers, which is R times cosine theta plus I sin theta. We can write this as RCIS theta. This R is called modulus, and this theta is called argument. You can find this modulus on this Argand plane. This is R. It's called modulus. So modulus equals square root A squared plus B squared. The angle between modulus and this positive x-axis is argument. So we have tangent theta equals B over A. For A plus BI, we can take square root A squared plus B squared out. So we have A over square root A squared plus B squared plus I times B over square root A squared plus B squared. This is cosine theta. This is sin theta. So we get R times cosine theta plus I sin theta. We do know E is called Euler's number. Therefore, R times e to the power of I theta is called Euler form of complex number or exponential form. Let's talk about argument theta. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Let's define a variable alpha. Alpha equals inverse tangent of absolute value of B over A. We call this is a reference angle. In this Argand plane, this is alpha. This is alpha. Here is alpha, and this is alpha. We can get this argument theta equals alpha in the first quadrant. For the second quadrant complex numbers, argument theta equals pi minus alpha. For the third quadrant complex numbers, argument theta equals pi plus alpha. For the fourth quadrant complex numbers, theta equals 2 pi minus alpha. We can also show the negative argument for the complex number in third quadrant and fourth quadrant. Theta equals negative pi plus alpha. theta equals negative alpha. Let's talk about when argument theta is special angles. First of all, let's talk about quadrantal angles. 0, pi over 2, pi, 3 pi over 2. For the first quadrant, reference angle is pi over n. N equals 3, 4, 6, which means pi over 3, pi over 4, pi over 6. This is 60 degree, 45 degree, 30 degree. For the second quadrant, n minus 1 pi over n. So we have 2 pi over 3, 3 pi over 4, and 5 pi over 6. For the third quadrant, n minus 1 pi over n. So we have 4 pi over 3, 5 pi over 4, and 7 pi over 6. For negative angle in the third quadrant, we have negative 2 pi over 3, negative 3 pi over 4, negative 5 pi over 6. In the fourth quadrant, 2n minus 1 pi over n, which is 5 pi over 3, 7 pi over 4, 11 pi over 6. Or negative angle, negative pi over 3, negative pi over 4, and negative pi over 6.